Hello, my name is Rosalie Hopkins. This is my second chem recitation video, and today we're going to be talking about Gibbs free energy. So, for Gibbs free energy, the process is you take the products, the energy of formation for the products minus the energy of formation of the reactants. So say I have an equation like this. CH3 CO2H. It's going to be a liquid plus 2O2. That's a gas, which is going to give me 2 CO2 plus 2 hydrogen dioxide. So for a lot of chemical equations, you can actually just look up online the delta G, which is Gibbs free energy. But we're going to solve for it. There's another method to solve for it if you have delta H, which is your heat of the reaction, and if you have delta S, which is your entropy of the reaction. So I'm just going to write what that is. Delta H is heat of reaction. Delta S equals entropy. And you can solve for these things in the same way you solve for this one. So like for heat, you'd take the heat of the products and the heat minus the heat of the reactants, and that would be your change in heat for the reaction. And the same is true of entropy. The entropy of the products minus the entropy of the reactants would give you the entropy of the reaction. So I went ahead and found these numbers. So delta H is going to be equal to, oh, and the formula for this would be delta G is equal to delta H minus T is for temperature times entropy times delta S. So Gibbs free energy is equal to the change in heat minus temperature times the change in entropy. So we're going to say H is equal to, for this equation, H is going to be equal to negative 764 kilojoules, and temperature is 25 degrees. I meant to say that up here, 25 degrees Celsius. So temperature in Kelvin is going to be 298.15 Kelvin, and then delta S is going to be 0.235 kilojoules per Kelvin. Okay, so then we're just going to plug that into this equation. So delta G is going to be equal to negative 764 kilojoules minus 298.15 times 0.235. Okay, and the answer you get from that is delta G equaling negative 856.1 kilojoules. Since the Gibbs free energy number is negative, this reaction is going to be spontaneous at this temperature. So if anytime the reaction is negative for Gibbs free energy, it's going to be spontaneous at that temperature. So if you can plug in different temperatures for different chemical equations, and it'll give you, it could give you a positive value. If the value is positive, then it's going to be non-spontaneous. And that just means that you have to add like a significant amount of extra energy from the outside environment in order for the reaction to occur. This will happen of its own accord. So thanks for listening to my video. I hope you guys learned something. Be sure to like, follow, subscribe, retweet, show all your friends, tell your pets, tell your mom about me. I really could use some subscribers. I only have 5. So just like watch the other videos while you're on my channel. Give me some views. Alright. Hope you guys have a nice day.